See, I work mainly on UK Pony, on nuclear deterrence and nuclear weapons policy issues, and for this session we're going to be talking about a game which occurred yesterday. Now, gaming's got several uses in defence, including forming part of the future force development. It's used in pre-op planning, and it's used for experiential learning. And here today is Andrew Reddie, who's going to be talking to us. He's a political science doctoral candidate. He wears quite a few different hats in terms of his research. He's done research for a lot of different organizations, as well as being a researcher for the project on nuclear gaming. He's the deputy director for the Nuclear Policy Working Group. He's also a CSIS Pony, well, was a nuclear scholar with them. He's now part of their mid-career cadre. He has a MPhil in International Relations from Oxford University, as well as a MA and BA from the University of California in Berkeley. And he'll be talking for about 25 minutes, and then we'll open up the floor for questions and answers. And so we should be done in about 50 minutes' time.
Perfect. Thanks, Sam. And my thanks to RUSI and Tom for inviting me on behalf of my team for allowing us this opportunity to share some of our research with you. I want to start by noting how impressed I've been with this morning's presentations. And it's really fantastic to see so many young scholars engaging on these issues. As Sam mentioned, I was a Pony nuclear scholar and am in their mid-career cadre now. If you're at all interested in what that means, feel free to find me during one of the breaks, and I'm happy to chat about that experience. So I'm here to introduce some of our preliminary results from our signal framework that was developed by the Project on Nuclear Gaming. Just by way of background, the Project on Nuclear Gaming is a Carnegie Corporation of New York funded endeavor. And without them, our work wouldn't be possible. So we're very thankful to them for their support. And it's a multi-institutional organization. So I represent UC Berkeley. I also worked at Lawrence Livermore National Lab until March before climbing into my dissertation cave. And then we also have a third partner, Sandia National Laboratories. And each one of these institutions brings something a little bit different to the project. So our UC Berkeley computer scientists, for example, played a significant part in the digital game. Sandia provided all sorts of systems analysis expertise and data analysis expertise. And Lawrence Livermore National Lab gave us a lot of the background on the nuclear weapons effects regimes. So the research questions that were pitched to Carnegie are the following. So how can we use war games as an experimental tool? So as Sam mentioned, war games have been used for all sorts of different reasons within military and also sometimes within the think tank scene with regards to policy-oriented questions. So they're really good for education, pretty good for training, but analytically, not always the tool that we turn to. And so we wanted to say, well, how can we use this wargaming kind of knowledge that we have and apply that to academic questions? And then our substantive or theoretical question is how might varying weapon capabilities have an impact on nuclear deterrence and strategic stability? So I probably don't need to say this to this audience, but different countries are making pretty important choices about what their nuclear arsenals should look like, and indeed what their conventional force structure ought to look like. But we're in the land of hypotheticals, and so there's no empirical data with which they could really kind of address those issues. And so we kind of thought about using this particular methodology to kind of get at that question. And you'll see some of those results here in a second. I should also mention that the partnering and mentoring objectives of the project are really strong, and we look forward to engaging with those of you that are interested in our project, and again, kind of pushing that next generation set of scholars to explore these issues, both inside the labs and also in an academic setting. So, do weapons effects change dynamics of conflict escalation? Do they alter the nuclear threshold morally, tactically, or otherwise? So those are the two questions that you're going to kind of see some preliminary answers to here in a second. Okay. So, research design. How should we study nuclear deterrence? The traditional approaches are numerous. In international relations research, we like to rely on empirical data where we can find it, historical cases. With regards to nuclear issues, that's a problem, right? We have an N of 2, right? With regards to countries, we have an N of 1. right? And we hope to not see any more N ever, right? But it's led to us having to look for alternative methodologies to explore these issues, right? So there's a reliance often in our field on formal modeling, right? Pure maths, right? Where you make assumptions about how the world works and how players behave, right? You build it out into some sort of utility function, and you say, okay, this is how a nuclear conflict plays out, given specific characteristics, right? We have translated a lot of that math into computer-based models, right? Running Monte Carlo simulations, doing them thousands and thousands of times to try to get some fidelity around the distribution of outcomes that stem from our math, right? And increasingly using survey experiments, right? So trying to actually generate data from humans, right, via survey where we manipulate the treatment that we're giving to players and then we see how they behave within the survey scenario. All of these approaches have significant strengths, but they also have significant weaknesses, right? I would say that predominantly with regards to IR research, we've been living in the survey experiment literature for a little while here. Some of you may have read Scott Sagan and Ben Valentino's excellent piece revisiting Hiroshima, right? But one of the major issues that you have with a survey experiment is that I give you a piece of paper and it's in front of you for 5 minutes, and then I take the piece of paper back, and then I'm going to assume, right, that you made a strategic determination about what the action was that you're going to make, right? Despite the fact that there's no cost associated with you marking A, B, C, or D, right? So one of the things that we're trying to do is to build a framework where your choices, right, inside something like a survey experiment matter, right? They affect, right, your life, at least for the next hour that we have you for a war game, right? So our contribution is experimental gaming, right? To try to move that literature a little bit further forward and offer a new tool in the toolkit, which is not to say that experimental wargaming offers a panacea. There is no one method that's going to offer us the final answer on what nuclear deterrence looks like or what nuclear warfare looks like. But having the variety of these tools allows us to get a better sense of what the answers to our important questions might be. Okay, and so as you know, wargaming has a long history. Seminar and scenario-based wargaming from Naval War College through RAND, through DoD, MOD, right, are very common. And are designed around identify policy challenges and are really, really useful for kind of saying, okay, I'm really concerned about the South China Sea. Let's build a wargaming scenario and put our senior policymakers in a space where they have to address the strategic challenges that they would have to address in that particular environment, right? With these games, we often see an open-ended architecture, right, where you're creating a very rich world. Some of these briefing books run to thousands of pages. I have a colleague at RAND who effectively wrote a book to start the scenario. And you play these games with some combination of blue cells, red cells, and then white cells that do adjudication, right? And very good, like I said, at engaging high-level policymakers, doing some training, doing some education, right, and getting them thinking about strategy, right? And so in the U.S. at least, one of the best examples of this framework that we have is the degree series, right, at the Naval War College. And indeed, we do some of this scenario-based seminar war games. That's a picture of me when I was a little bit younger, playing with some of our slides for that at the lab. But these existing wargaming methods also have limitations, right? You can't very well do outcome-oriented inference on them, predominantly because they're often only played 1 time, 2 times, 3 times, right? It doesn't allow you enough variation, right, to actually say something meaningful about how the world is likely to work, right? So it doesn't do us much good to say, okay, here's your South China Sea scenario, right? And I'm going to go play it with 4 or 5 policymakers and then write an article that says this is what a South China Sea scenario is going to play out like, right? We can't do that, right, with single-play war games. So one of the things that we wanted to provide was a framework that you could actually do large N analysis on, right? And then also try to imbue that war game with some of the experimental standards that we look for as kind of social science researchers, right? So what are those characteristics? Well, the first thing you do is you want to create a platform that's replicable and reproducible, right? You don't want to have things like a white cell that are going to introduce bias, right, to how the game is being played, right? You want the same rule set to affect all the same players every single time that you build the war game. You also want to be able to control the variables that you think are important, right? So I gave you those research questions before, right? And we picked a very specific independent variable that was of interest to us, weapon capabilities, right? We vary that one capability, right? And we compare all those various treatments against an outcome, right? In this case, the nuclear threshold, right? Or conflict escalation, right? So you have kind of exquisite control of your experimental environment. You're also able to capture data about everything that the player is doing, right? From chatting within a war game, speaking to each other over a game board, to actually capturing all the various moves that they're making, some nuclear related and some non, right? You also don't want to have researchers involved in the game, right? So none of our war games involve members of the game staff saying, have you thought about doing this, or you should do that, right? We're completely outside of the gaming framework, and that's really important as well. Okay, and then does it actually incorporate enough complexity, not too much? Some of you played the war game yesterday, right? And I think the feeling in the room was that it was just about complex enough, right? But not too complex. But you do want to try to imbue it with enough external validity that you can say something meaningful about the world, right? And so Signal version 1 kind of represents our first kind of foray into this space to kind of demonstrate that this concept is valuable and needs to have more, to be quite frank, money spent on it. It does cost a lot to kind of build these methodological frameworks from scratch. And so it's kind of our first take. This is actually a picture of the board game, which I think some of you might have played at King's College. So one of the things that we've tried to do is to incorporate kind of some of the essential elements of deterrence across military, economic, and diplomatic aspects, and also incorporating some of the dynamics of deterrence, whether that's bargaining, signaling, and some of the uncertainty that's imbued with regards to like what your adversary is actually likely to do. Okay. And so like I said, we use kind of an experimental way of doing this, and we have more or less 4 products, if we're thinking about it like selling a bill of goods. So the first one is Signal Online, which some of you played yesterday, where we have a highly structured scenario that has a very specific rule set that players have to kind of play through, and automatic quantitative data collection on the back end, right? And that's exactly what it looks like. And then we have the board game, as I mentioned, that has the same rule set, but actually allows for over-the-table dynamics. One of the reasons that we have the board game, well, I guess the first reason was to test how to build the online game. But one of the other things is kind of we're interested in the laboratory effects, right? If you're sitting at a board playing an adversary across a board, things might look different than if you're behind a computer screen. Right? One of the kind of assumptions that is out there in the literature is that we all get in front of a computer screen and we all become really aggressive and do crazy things. And so we wanted to kind of test whether that was true. So we actually built both. And I'm actually going to show you some of the data that we've generated from that board game. And as I mentioned, we have that TTX that is more fluid, right? It doesn't necessarily have a structured rule set. It does have controlled team adjudication, but it tries to push on some of the same strategic questions that are at issue in the board and the online game. And then we have a survey experiment, right? And the reason that we have the survey experiment is that it allows us to benchmark our results against what is the state of the art currently in the social science field. Okay, and so just a little bit of background on the game. So the game is 3 players, is 1v1v1, and it's an abstract game. So we have an orange team, a green team, and a purple team, okay? So we're trying to get our players away from the real world, right? So we've chosen a map design that we hope stops them thinking that they're America and that their adversaries are Russia, or that they're Russia and their adversaries are China, right? We try to avoid the colors that have those kind of characteristics, and we're not playing out specific country scenarios, right? So you're not going to take our gaming framework and say, well, that's the Strait of Hormuz, right? Or that's the Straits of Malacca, or what have you. So that's kind of some background there. So like I said, I'm going to show some data from our board game play, and kind of show you some of the statistics and inferences that you're able to draw off the back of this. We have 46 games coded up, and 46 might sound like a fairly small number, particularly for those statisticians in the room that are used to working with millions of data points. It is the largest data set of war games that's been collected for social science purposes. The previous largest was the 26th that Reed Polly put together for an international security article, and that was archival wargaming data from MIT and also DoD, and those were the Schelling-Bloomfield games. Interestingly, that data set is comprised of unlike units, right? You have some of those war games that are dealing with Korea, other ones with Vietnam, other ones with Cold War. This one's all the same game, all 46, right? So makes it really nice for comparison, right? The board game tests 2 experimental conditions. In one experimental condition, we provide players with what would be a high-yield nuclear weapon, right? And that's the only nuclear capability that they get, okay? In the experimental treatment, we provide players with that high-yield weapon and also a low-yield precision strike nuclear weapon and a nuclear EMP device, okay? And then we take those two experimental conditions and we compare what the outcomes look like, right? Very basic experiment. And here are some of the kind of overall kind of results. Split into all rounds and last rounds. The idea behind this slide is not necessarily that you look at all the numbers. The idea behind this slide is to say that these numbers don't change all that much across traditional Taylor, like it's not completely uneven between the two, okay? This method is really useful because it allows us to look at the trends in player behaviors and strategies. So this is a picture of the board game map that the players are playing on. This map is also identical to the one that those of you that played the e-game played on yesterday. And one of the really neat things is we can kind of show the flashpoints, right? So where are kind of players meeting each other on the board and having a fight over a specific resource or territory, right? And you see a lot of that in between, as you might expect, orange and purple. And then you see a little bit around the islands as well. Okay, so you kind of can do this really nice data visualization work. Here's another example of that. So one of the things that we do for conflict escalation dynamics is tracking player actions over time, right? And so what you can do is you can map what the game is doing across each round, right? And you can say, okay, well, I have nuclear use happening, and usually that's coming from some sort of multi-front conventional action first, right? You can kind of draw these statistics from that. One of the things that eventually you can do with this is actually to get transition probabilities from one kind of conflict class to another, where you can say, okay, if I launch a conventional missile threat, what's my predictor probability of doing X next, right? So we haven't kind of got the math all sorted for doing this appropriately yet, but this is kind of a way to visualize that data moving forward. And the blue one there is the control, and the red one there is the tailored. And you can kind of already see just on the basis of this one graph, right, that the blue arrows look a little bit different than the red arrows, right? So the players are playing the game differently based on which nuclear capabilities that they actually have, right? Or at least that's what's coming out of preliminary data, okay? So the political scientists among you will appreciate this slide, and the rest of you will probably not. I'm a political scientist, so you're getting my probit regression results. So what does this regression show? So it's basically saying that, look, when we run a conditional probability model on our data, that you're statistically more likely to have you're going to have a higher predictability of nuclear use if you have more nuclear assets in your arsenal, okay? And this result is robust both when we include the last round and don't include the last round. Okay, and you might be asking, well, why are you going to take out the last round? Well, in game theory, right, if any of you played Battle of the Sexes or Chicken, right, you're very likely to cheat in the last round of a game, right, and get all the benefits that you can, right? And so we see that behavior in our game framework. It doesn't change the statistical significance of the results, but we do see players doing crazy stuff on the last turn because they want to do crazy stuff on the last turn. But one of the arguments that was put to us is that, you know, the true reflection of player behavior won't happen in the last turn. So you need to run the analysis both ways, which we've done. You can kind of see the results here. Okay. And again, I should stress again, this is preliminary data. So, you know, the academic articles that you see emanating from this, as we add the thousands of playthroughs that we're getting on the online version, may not reflect this slide. Okay. And then one of the other things you can do as far as the political science analysis is concerned is to run a survival model, right? So instead of asking the question in binary, right, will a game go nuclear or will it not, you can ask the question of, well, when, right? And so here in red, you have the control game, and in blue, you have the game where we give players the additional nuclear capabilities, and the survival probability, right, and survival in this case is staying non-nuclear, decreases quite significantly and fairly quickly if you have more nuclear weapons at your disposal versus when you don't, okay? Cool, so I'm actually gonna freeze it here for just a second. So with regards to these outcomes, right, we're not tracking the best strategy. We're not tracking who's winning and who's losing, right? All we're getting out of this is we're giving a player a specific set of capabilities, and then we're saying, what did they do with that, right? And then we can say, okay, what they're doing with that's really interesting, right? And so that's kind of what we're going to be testing for, okay? So that also marks a little bit of a departure away from some of the traditional TTXs that are kind of more geared towards, well, what's the appropriate strategy for dealing with, adversary A versus adversary B, right? So again, very much set up as on an experimental basis, okay? So you've seen kind of the preliminary results that we have to date. With regards to kind of where we move from here, Pong is in kind of this box here. So we've created human-generated experimental data. And as I mentioned before, there's other researchers that are creating all sorts of alternative data sources. So you can use actually commercial video games and try to draw inferences from that. And we actually have a part of our team at Sandia that's put in an application for doing some of that work. We also have real conflict process data that we can say loosely approximate some of the deterrence challenges that we're dealing with. So you can throw some of that in. And then one of the other things you can do with our human-generated data is to construct machine learning models or run machine learning on the models and create kind of AI players, if you will, to actually do some human-machine play. And so these are kind of some of the things that we're interested at doing moving forward, right? And again, the idea here is not to say, hey, this particular policy produces the best set of outcomes. It's just to add, again, another additional tool to the toolkit at which we kind of try to address nuclear issues moving forward. So with that, this is our team. It looks like a lot of people, but I can assure you when you're trying to build a video game from scratch, it's not. With that, I look forward to your questions. And we are on Twitter. We're very hip. And we have a website, which is maybe less hip, but that's actually how you can access the game. We have play windows every Wednesday, and also I run them, so I've scheduled quite a few that hit your guys' time zone. Which is really early in the morning in San Francisco. So, please do stay in touch. And we have a few articles. This is the most recent one in the Bulletin of Atomic Scientists. We had a piece in Science in December. But I think overall, kind of thinking about how experimental scholarly inquiry can kind of mesh with kind of traditional wargaming tools is proving a quite fruitful avenue for research and addresses some of the weaknesses that exist in current social science methods quite well. So look forward to your questions, and thank you again for the opportunity.